Hello, Fiserv. I'm Dion.
I'm Shosh.
I'm Mayuk.
I'm Ann.
And we're Team Titans.
And today we're excited to introduce our secure biometric payment system built for the future of fintech, BioPay.
Our solution uses encrypted, segmented fingerprint data to authenticate payments without ever exposing a full biometric identity.
Today's digital payments rely on passwords, PINs, and physical cards, all of which can be stolen or compromised. Biometrics solves this, but most systems still store or transmit full fingerprints, creating serious privacy and identity theft risks. We wanted a system where users can authenticate with the fingerprint without ever sending or storing the actual fingerprint. Our goal was to create a payment method that is fast, secure, and impossible to reconstruct even if data is intercepted. The prototype uses the following technology: an ESP32 Wi-Fi microcontroller, a fingerprint sensor, a Python backend server, the FAISS similarity search algorithm, and encrypted Wi-Fi communication.
Here's how our solution works. When a customer decides to enroll their fingerprint with Fiserv's BioPay at any payment terminal that is capable of BioPay, they must link their bank account details, specifically their bank UID or other identifiers, with the compatible banks, as well as scan their fingerprint. Afterwards, the terminal will post a bank ID and a fingerprint hash. In our program on the right, the sensor gives us a 512-bit template of a fingerprint. Instead of storing or transmitting that directly, we compress it to 256 bits of a locality-sensitive hash. For each output bit, we randomly sample multiple of those from the template and use majority voting to determine its value. Because the sampling is deterministic, the same fingerprint produces the same hash. This gives us a compact and non-reversible representation of our fingerprint that is suitable for fast similarity matching. After the creation of the representation of the fingerprint, that hash is sent with the user label to a server. The server stores it and inserts it into a JSON index for fast timing distance matching later. It does so by using this Python function on the right to write to that file. Remember that this fingerprint isn't actually their exact template, but a numerical version of it used specifically with BioPay and a template that cannot be reversed. Next, when the user decides to pay using BioPay, they scan all their items and during the checkout process, scan their fingerprint. Then this fingerprint is divided into a grid of 6 by 6 and 5 selections are selected based on the most detailed and are hashed together. Here the program on the right divides the hash into the 36 sections and chooses the best ones in their fingerprint detail. This is then sent along with the transaction time and merchant ID to ensure that the transmission is secure. Then the server with BioPay will use FAISS, which stands for Facebook AI Similarity Search, to compare the partial data against a secure biometric index full of everyone else's fingerprint hashes. Then FACE returns a match UID or user identity, which enables the payment and starts to communicate with banks to finalize the transaction. Since only 5 out of 36 hash fragments are transmitted, even if someone intercepted them, they couldn't reconstruct anything meaningful. Nothing is stored locally, nothing is exposed, and every transaction uses a slightly different combination of segments for added security as well as the time and the merchant UID.
Fiserv already processes payments and identity validations at a massive scale, and our server-side authentication model fits directly into that ecosystem. Two careers are at the heart of making a system like this possible. The first one is a cybersecurity analyst. At Fiserv, these professionals ensure every layer of a payment system is protected against threats. Cybersecurity analysts ensure encryption, secure data transmission, threat modeling, and privacy protection, critical for safeguarding millions of users. Fiserv handles data for millions of customers, and cybersecurity analysts are the ones making sure that trust is never broken. Machine learning engineers design scalable algorithms like FAISS to authenticate users quickly and accurately. FAISS is exactly what a machine learning engineer at Fiserv would build or integrate to authenticate millions of users without sacrificing speed or accuracy. As biometric payments grow, machine learning engineers will be critical in keeping those systems fast, fair, and fraud-resistant. Together, these roles show fintech innovation isn't just cool technology, but about building secure, scalable technology for real-world use.
Our biometric payment system allows users to authenticate quickly and securely without ever exposing their full biometric identity. It's private, reliable, and designed for real-world fintech deployment. We're excited to help shape the next generation of secure digital payments.
Thank you, Fiserv.